What is up, everyone? In this video, you're going to learn everything you need to know about Kirchhoff's current law. Commonly abbreviated KCL, it's one of the two fundamental laws used to analyze electric circuits. It is based on a simple but powerful principle where electric charge cannot be created or destroyed at a junction. That means that the amount of current flowing into a node must equal the amount of current flowing out of that node. Now, we typically express this mathematically by stating that the algebraic sum of all current entering and leaving the node is equal to 0. Now, before we look at an example, let's define what a node actually is. So a node is a point in a circuit where two or more conductors are connected. Here we have an illustration where a node labeled A, we have 5 conductors either enter where it's connected to the node, and we have the currents flowing both into or out of the node. Now, to apply Kirchhoff's current law, we'll first apply and identify all the currents either entering the node or exiting. For entering, in this example, we have currents 1, 3, and 4 all entering. For the currents that are identified as leaving the node, we just have currents 2 and 5, and that's just represented by the arrows. So, according to Kirchhoff's current law, the sum of the currents entering the node must equal the sum of currents leaving the node. So, current 1 plus current 3 plus current 4 is equal to current 2 plus current 5. Now, as long as this relationship is satisfied, electric charge is conserved and the circuit obeys Kirchhoff's current law. Now, it's easy to dump a lot of definitions and illustrations towards you, but now let's work through an example to sort of see how this is used firsthand. So, we have a node A, yet again, with 5 conductors connected to that node. And we have the arrows along with the currents for each of those conductors. So remember that current in equals the current out. First, let's identify all the current in conductors, and that is the 1 amp and the 3 amps, which are featuring the arrows going toward the node A. Now, for the current out, we have the 2 amp, the 5 amp, and we have an unknown current on one of these conductors, which is just going to be a question mark for now, and we're going to actually be tasked to find what that current is. So with all those values known, except for the unknown, which is what our task is going to be, we're going to have the sum of the in equaling the sum of the out. And we can rearrange that formula in terms of finding the question mark, and by doing simple addition of subtraction, we determine that the unknown value of that current is -4. Now note that's a negative value. So that actually implies that the direction that arrow is for the unknown is actually going to be reversed. So it's actually a current of 4 amps going towards node A for this instance. And the use of Kirchhoff's current law is very useful when looking at current in circuits for either being connected in series or parallel. So we have current in series where, for example, here we have just 2 resistors, and the current at node A, node B, and node C are all the same, while the voltage is shared across resistor 1 and resistor 2. Now, looking on the right illustration where we have current flowing in parallel, the current between nodes A and B is equal to the current between C and D. Now, obviously the current between B and C is the same, however it branches into 2 paths, so basically the electrons flow and branch off. So the current between and across resistor 1 is, say, I sub 1, and then the current across resistor 2 is I sub 2, and the sum of that is equal to the current. If you made it to the end of this quick crash course on Kirchhoff's current law, give yourself a pat on the back. Now, this is just a quick introduction to the Kirchhoff's current law. Next, we'll be covering the Kirchhoff's voltage law, which is the second fundamental law of understanding electric circuits. Make sure to go check it out when I post it. Hope you guys enjoyed. Make sure to give this video a like and subscribe.